Is there anything that you'd like to talk about from 2.3 that we haven't talked about yet? The one that we're like supposed to finish last night? 71 to 75. Okay, so I'm not going to do all of them. Let's just either 71 or 73. Which one would you like to look at? 73. Okay, so the whole key on 73 is this information they gave you. I don't know how you would factor it without this. So and the key, make sure you guys read it. They should probably say A is a real number, yeah. So again, why do we even need to mess with anything on this? Because if we plug in as is, we get a 0 in the denominator. Okay, so we need a factor, and we need a term like this, right, to cancel. So the formula just says, right, x minus a there, and then x is decreasing. I'm probably going to run out of room. X is decreasing by 1, so then we got x to the 4th plus, right now we work in a, x to the 3rd. I'm going to run out of room. And then, right, a squared, x to the 2nd. I'll put it down here. Then plus a to the 3rd x plus a to the 4th. And right, I wouldn't know that except by looking at it, right? So now these things can cancel. And then we have this. So is there any questions about this part of it?
Not for this problem, but for what if the a value is greater than or what if the n value is greater than 5? How do you plug it in? Where the ellipses are in the form? I don't know. I guess I just don't understand your pattern you're plugging it in.
Is ellipses like dot dot dot?
Yeah.
Okay. So all we're doing is did we do the binomial theorem last year? Probably not. I think I did that in algebra too. Did you guys ever do binomial theorem? Like Pascal's triangle? You know, like, Tim, you know what I'm talking about? That's what this is, basically. So the pattern is every term, the x value, right? We're starting with this one. Every term, the x value goes down by 1 until it's gone. And then after the first one, you introduce the other one, and it goes up by 1 until you reach 1 less because we factor something out. Okay? Is that okay with everyone? I guess you should know that. There's not a very good chance that you're going to be asked that anytime at all. But you should know it, I guess. But all right, so what do we do now? What are we doing now? Yeah, so now we are allowed to plug in a, since we're not going to get a denominator. And so then this is all going to be a to the 4th plus 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 a to the 4th. And then 1, 2, 3, 4, 5, a to the 4th. Is that okay? Yeah, I mean, technically you should know binomial theorem, but whatever. Like I said, if you get asked that, that's the only thing you can't remember. I mean, you're doing fine. But they gave it to you here, so they don't really expect you to pull that out of your ear, So. Anything else? Creating functions satisfying the given limit. Let's go. See what I know. So, does anyone got anything to go with? Why is this like, you ready? Like, why is this like, huh? Well, I know, but like, what makes this like kind of like weird?
Well, first of all, there's equity, that's not, that's fine for that.
Yeah, right. So you're trying something different. You know, when I read this, like, what I think is weird is like, wait a minute, how are we getting any number besides 0? Because now we're multiplying. Right, so that's kind of weird to me. But what could... Let's just concentrate on F. Give me something that... Right, because this is what they're saying. As x goes to 1, whatever this is goes to 0. Okay, so she's saying this, which is fine, because like if we go to 1, are we getting 0? Is this the only thing that we could use?
Just need any point that gives you the code, or any form that gives you the code 1, 0, 1, or 1.
So it could just be x minus 1. Yeah, right. Like the squared is fine, but it could be just x minus 1 even. So then basically what we're saying is okay, so because this is also what they're saying. And so then because so like what is the problem like with this right now? Because like what needs to happen for us to be able to get say it again. So like right now what like we don't have anything in there right now, so like what's right, because like so yeah, so that's a problem because like how are we getting 5 if we're multiplying by 0? This is kind of like the reverse of the questions that we've been looking at. Like we got these rational functions that we deal with, and like it's like we got 0 in the denominator. Like what are we supposed to do? So this is like kind of the reverse way of thinking of that. So what were our options when the denominator becomes 0? Cancel it out by factoring, or or the conjugate. Yeah, okay, so I put the squared in there because that's what we started with. But yeah, whatever you started with. So if we had this, and then just a 5 on top, yeah. Is that okay? Because we still can't get to 1 by our limit, right? But now we can cancel it, so there'd still be a hole there. Like if we try to graph this thing, there'd still be a hole in our limit, but then right now they can cancel each other out. That's a cool thought. Like, right, that's kind of fun. I mean, if you're into that kind of stuff. Anything else? Okay, so kind of similar, it looks like. Alright, so P of X is that thing. Right, and then as it goes to 2. P of x over, oops, x minus 2, right?
Yeah.
And it's 6?
Yeah.
Okay.
I know that like the p of x has to have something times x minus 2 so that the bottom cancels out. I think I got this one, but like I just feel like I got it like in a lucky way. I didn't feel like I really understood.
Well, okay, so, you know, a lot of these, like, it's just more of a thought process, like, you know, you're kind of building skills. So, you know, I don't know if you're lucky, I mean, it's still, like, you have to think through it, so, but we should definitely do it. So, what do we need to have happen with P of x? Yeah, so we know that P of x, when it's factored, is going to be x minus 2 times something, right? So we do know that. And when we plug in 2, it's going to have to equal 6. Right, because this one and these two will end up canceling. So whatever's left here has to equal 6 when x is 2, right? And we don't have you know, we don't have any a term. Does that give us 6 there? Right? Because remember, you know, we're over x minus 2. Oh, right that way. Right. So this one's going to cancel when we plug in 2. So this had to be 6. So then x squared plus 2x minus 6. Is that okay? I know these, you know, we're up in the 80s here. Like, these are thinking problems, you know. Yeah, of course it is. Yeah, thank you. Yeah. Only if you're multiplying correctly is it minus 8. Is that okay? But it's just a thought process, right? I mean, like, you know, it's weird to go through this stuff. Okay, so is that pretty good? Let's go over our 1 through 10 there at the beginning, and then we can move to the next section. Next section is not too bad. Okay, it's we got to do it in one day to keep on pace. But when you look at it, you know, there's 30 questions or something, but they're not that bad. So let's look at the review. How is the limit as x approaches a of x calculated if f is a polynomial? Plug it in. Plug it in. How are the left and the right hand limits calculated if it's a polynomial function?
You just plug it in.
Yeah, you just plug it in. 3, what values of a does that hold true if r is a rational function? Yeah, essentially everything as long as the denominator doesn't become 0. Okay. Assume as x goes to 3, it's 4. That one's 4. Assume that they're the same. Whenever x does not equal 3, evaluate that.
This is the other one that equals 4.
Yeah, is that okay? Why 5? Why? I'm not gonna read that to you. Why? Yeah, right. So you got to factor and cancel first, right? Again, 6. Like, you guys don't need me to read too much.
Yeah, it's mainly. Wait,
Yeah, you got to do something though.
negative. No, 4.
So I think it's just 4.
It's 4. This is negative 2 squared.
Yeah, because it should be negative 2 squared. Is that okay? Does everyone see that? Right, they're just basically that's a limit law, right? That's our thing right now. Number 7. Is that okay? 20, just another limit law. Number 8. What are they talking about there? Squeeze theorem, so then right, remember squeeze theorem is talking about you can't find the limit of the thing that you're trying to find, so then you have to shove it in between two things that go to the same, yeah, that's one's greater and one's always less than, and if you can show those limits go to the same thing, then you say, okay, by the squeeze theorem, this middle thing goes to the same thing, so then 5, right? Another limit law, 1 on 9. Is that okay with everyone? 4? And then finally 10. And 10's actually a nice, talking about 10 is a nice lead into our next section there. Okay, so is that okay then? The first one's 4 and the second one's 5. So hopefully you feel good about these. I mean, you know, they're not awful. Really, all you're just plugging in numbers unless you can't, and then you got to do something to them, right? So when you guys are looking at the second part of 10, how did you decide where to plug it into? So then we're approaching from the right, so that means we're grabbing numbers bigger than 3, right? And that's why we're down in the second one. So give me examples of like if we were doing this by a table, give me a number, because remember the idea of a limit is that we keep plugging in closer and closer and closer and closer numbers to see what f of x goes to, right? So like, give me an example of a number. If you were doing it that way, you would plug in for x approaching 3 from the right. 3.1, 3.0001. Okay, is that okay? All right, so let's keep that in mind when we go here to the next section. So flip up to page 87. And we got 2 different things to talk about. Just one today, but then the other one will start tomorrow. And that's infinite limits and limits at infinity. So the first thing we're talking about is like what the heck the difference between the 2 are. And we actually, in pre-calc last year, we spent a little bit of time talking about these. And so this is like asymptote stuff. So a vertical asymptote is what we're talking about today. That's an infinite limit. And so what that means is as we approach a certain number on the x-axis, y is growing incredibly large in the positive direction or incredibly large in the negative direction. The other one that will start tomorrow, limits at infinity, are your horizontal asymptotes. So as x keeps increasing, does y go to a certain number? Is that okay? That's the difference between the 2. Now, for the most part, I don't know that you got to keep them straight, but for the next 2 sections, you got to keep them straight. So there's an interesting thing. You know, again, I suggest that you guys read through this. You know, we just don't simply have the time to go through everything. But here in the overview, they say something really interesting. It's like the 3rd sentence there. Because f of x does not approach a finite number. So, okay, so think we're looking at this table. This is the limit as x approaches 0 of 1 over x squared. And so as we get closer and closer to 0, the y values keep increasing like really high. And so they say because of x does not approach a finite number, that limit doesn't exist. Because that's kind of like the definition of a limit. It has to approach a certain number. But this is not approaching anything, and so really the limit never exists. But then we say that it exists, it goes to infinity. So it's like a notation thing. And so it's just kind of weird, okay? So all we're talking about is like, oh, look, it's going to some giant number, but the limit doesn't really exist. Is that super confusing? Or like, it's weird, I think. All right, and so then if you flip over to the page, the next part is just talking about the horizontal asymptote, right? And you can see down in right there next to the table 2.7, they're showing you the notation. As x approaches negative infinity, y approaches 0. And then as x approaches positive infinity, y approaches 0. Okay, that's the difference of the two. We're not talking about that one today. We're going to talk about only vertical ones. Okay, so as x approaches a certain number, y is growing out of control. Down here, definitions of limits. It says that it's not precise, but we're not going to be able to do the precise definition of it, so that's the one we're going to use. And I basically said it twice now, or 3 times, right? X goes to a finite number, y goes to infinity or negative infinity. And so then, part of evaluating these is by the graphs, and so then they talk about that, if you're looking over on the next page, figure 2.25, right, as x approaches 1 there, from both directions, right, y is approaching positive infinity. And then as as x approaches negative 1, y approaches negative infinity. All of our other rules are still the same, right? Like, if you want to say that does this limit exist, it has to come from the right and the left at the same go to the same place. Okay, if that's not true, that limit doesn't exist. You still can answer from the right and from the left, but then you would have to say the overall limit does not exist. Is that okay with everyone? Okay, and so then the definition of one-sided infinite limits are just a definition of one-sided normal limits that we did in the last section. Is that okay with everyone? Because we're going kind of fast. All right, so flip over to the page here. All right, and then they say that that's a vertical asymptote, basically. Right? If that happens, right, like you're looking at the definition. If, as x approaches a, f of x goes to positive or negative infinity, and then they have these other two statements, from the right or from the left, then the line x equals a is called a vertical asymptote, right? We did this is like basically what it was last year, right? So it's the same stuff. And how do you, like, before we go on, like, do you guys remember how to find vertical asymptotes from a rational function? So here, let me, I'll just come up with something here. Right, this is like from last year. Let's do, it's hard to think. Find the zeros on the bottom, right? This is a vertical asymptote at x equals 6. Okay? At first glance, you would say 4, but what if I told you it's not, there's no vertical asymptote? Right, so this is like 1, right, with a hole in it. Okay, so just be careful, okay? Right, if you're asked for a vertical asymptote and you say this one is at 4, then you're actually wrong because there is, because that would look like something like this, right?
So if it was like a polynomial and the denominator would be more than 1.
Yeah, right, so if you had like some cubic, you'd have potentially 3, that's a generalization. That's not always true because you could have like a double one and, all that kind of stuff. But yeah, for the most part, yeah. Okay, so again, the important thing is, if it cancels, it's a hole. If it doesn't cancel, then it's a vertical asymptote. Is that okay with everybody? All right, so quick check at the top of page 90. Why don't you sketch that? Quick check 1. What is it going to look like? I think you did that backwards. Right, should it be like this? And then like that? Is that okay with everyone? Yeah, so they didn't give us anything else. And actually, you guys are going to have like some of these coming up where you guys got to create what they're describing. And there's tons of right answers. Okay, you can only, what they're giving you is the only thing you got to worry about. The rest of it is kind of like your artistic, whatever. All right, so remember I told you to keep in mind about number 10 there. Okay, because what you guys are going to do is like do a lot of these by the graph. But then they say analytically. And so as you approach a number, you're getting like really small intervals that you're testing, right? That's what this analytical part is about. So, it's in the book. I'm going to use the same examples as in the book. But we'll just talk it through, and then later on, if you need to look at it, like it's like your notes are already taken kind of idea. All right. Why is this even something that we're talking about? Like, and so when we're talking about analytically, you're thinking of plugging numbers in and things like that. What's going on when you get a vertical asymptote? Right, the vertical asymptote here is at 3, right? So what's going on there? And you can punch it in your calculator to take a look at it. But what's going on? Like, why does this, when we get closer and closer to 3, why do like things like this happen? Could you guys hear what we said? Can you say it again? Because we're dividing some number, it doesn't matter what number it is, by something smaller and smaller and smaller and smaller. So it's going in more and more and more and more times. Right? Because you guys got to change your thoughts about small numbers, right? We're talking about, we're talking about dividing by like these kind of numbers, 10 divided by that, right? It's going to go in all kinds of times. And so that's why it's really growing that much. Is that okay? Does that kind of make sense? So let's look at the numerator only on this. Like ignore that we're even with a fraction right now. So how would you evaluate the limit as x approaches 3 from the positive side of 2 minus 5x? Yeah, you just plug in 3, so what would this be? Negative 13. Okay, so we know that the numerator is going into something like that. And now this is where this is going to make a big difference. We're plugging in numbers, and you're answering bigger or smaller than 3 here. bigger. So then it's approaching zero, like positively. Does that make sense? So then is the answer to this positive infinity or negative infinity? Why is it negative infinity? Because it's a negative divided by a positive. Is that okay? Let's do another one of this. Oh, they just switch it up. So right now we're coming from the negative side. What's going on in the numerator? We're still going to negative 13, right? But now are we plugging in values bigger and smaller than 3? So then this is still approaching 0, but then it's negatively approaching 0. And so then this is positive infinity. Is that okay how that works? Now you can always check this out, right? You just look at the graph and it better be doing what you're saying. But that's like kind of like why it is doing that. Are there any questions on that?
So that's also true when it's not going to be at like 0, right? So like if it was like 2x minus 6, like it would be approaching 3 from the positive side.
But it does still matter about the numerator.
Yeah.
Oh, okay.
No, I'm saying like it's not always going to be like the denominator is not always going to be 0 from the positive or negative. Like it could be like 6 from the positive.
Yeah, I don't know what they, I don't know how they, I don't know.
If the asymptote was at like y equals 6, like 0 and 6 would be 1.
Yeah, we probably wouldn't be going to 3.
Yeah, I'm just saying that.
Yeah. So we're still going to 3. I mean, yeah, your overall thing is true. Like it does depend on which side you're coming from of what's going on, right? Like, is that value being negative or positive? I just don't know that you're going to spend a lot of time looking at things that don't give you a 0 down here. At least in this at least what we're talking about today. Okay. Make sure your faces are in those masks. So they got another one. Should we do another one of those, or what do you guys want to do? We don't have a ton of time, but like I'm basically done. Yeah, they got some trig in there. Yeah, you're gonna have to do trig. Remember I told you last year that the idea is that you know what these shapes are for this kind of stuff, right? Like, and if you don't remember, like, then plug it in and look at it. You know, it's hard to remember what they all look like. Okay. All right. Okay. So it's just 7 through 57 odd. So that's kind of a lot, but like, I mean, there's not, they're not really that time consuming. Real quick, if you look at 13, do you understand the window they want you to look at? On 13. Yeah, so that's like x's from -1 to 2, and then y's from -10 to 10. Okay, that's how they're writing that. Okay. All right, so the key pace, we gotta go that fast, but I don't think you guys are, this isn't like awful. Make sure you're factoring, simplify before you try to plug stuff in. Definitely simplify. I'm looking up here at number like 27. Factor all that and cancel what you can. 25, same idea. Factor. 23, same idea. Cancel and factor, etc. And remember, it has to agree, right? Real quick. Right, that limit exists. But that limit doesn't exist. Right? Right, that's still true. All right. please ask. Don't be afraid to come in and talk, right? Like, this stuff gets confusing, and I don't have a way to really, I think you guys are doing okay on the quizzes and stuff. But I don't really have a way to judge until the big test next week, so. Next section isn't a big deal, but the section after is a lot of information. Like, I can't even give you guys any more of the AP stuff until we do the last section of the 2.6. There's a lot of stuff. It's not hard, but all of a sudden it builds up and you gotta like use it all. It's weird. Okay? We'll go over it, you'll be like, yeah, okay, that makes sense, fine. But then you gotta state it. Okay? So please ask. I want to help you. Will, how's that? Will, is that okay?